Hello, friends. Welcome to my YouTube channel Electrical Hub. We have started the series of generator protection. In the first part, we have discussed about the dead machine protection. So, if you have not seen that video, you can go and watch the video. I will provide the link in the description box. Here we are going to discuss about the Stator earth fault protection. It is of two types. One is 95% and 100%. We will discuss why its limitation is up to 95%. Why not 100%? And what is required for the 100% protection? We will discuss in details. From this drawing, you can understand that the stator windings are connected in star connection at the load side, which is the left hand side of your diagram. The neutral, which is going to the ground, is passing through the neutral grounding transformer, and there is also a load register. Engineer is connected with the secondary of neutral grounded transformer. So, what will happen during the normal operation of the generator? During the normal operation, no current will flow through the neutral. And as the current is zero, so no current will also be induced in the secondary winding, and there will be no voltage drop across the NGR. But if any of the stator winding is earthed, then a huge current will flow through the neutral line, and it will induce the current in the secondary of the NGT, where a load resistor NGR is connected. So what will happen? As the secondary of the NGT got induced with the current, it will also flow through the NGR, neutral grounding resistor, which is connected along with the NGT. So as the current is flowing and there is some resistance, so there will be some voltage drop, and that voltage drop will be sensed by the relay, and it will trigger a tripping. So this relay is voltage sensitive. Sometimes there is also one another method called open delta is used, or sometimes both the methods are used. So what happens in the open delta connection? During the normal operation, there is a balanced current flowing which, due to the 120-degree displacement additive, it becomes zero. But if one of the winding is grounded, then there will be an unbalance in the current. Due to the unbalanced current, there will be a voltage drop, and that voltage drop will go into the relay, and since it is a voltage sensitive relay, it will trip the alternator. Why the limitation of 95%? First, let us clear which part of the winding will be protected by the relay and which part will be not. So, at the neutral end, the 5% of the winding will not be protected by the stator earth fault relay, and that is why it is known as the 95% earth fault protection relay. And the remaining of the 95% of the winding will be protected. The question comes, why this 5% of the winding will not be protected? This 5% of the winding will not be protected because of the low voltage magnitude at this region, which, if any fault occurs, then low current will pass through the neutral grounding transformer, and similarly, the low current will be induced in the secondary, and there will be a very low voltage drop across the engine. May the relay will not trip. Now the question comes, why we cannot reduce the setting so that if there will be a voltage drop, the relay should trip? It is because due to the unbalanced load, there can be a small amount of current flowing through the neutral grounding transformer. But if this part is also taken, then it will always trip. That is why through this relay we protect only 95% of the winding. But all of us know that 100% of the stator winding is protected. So, how it is protected? It is protected by the voltage injection principle. What is the voltage injection principle? The voltage injector will inject low frequency AC voltage through this secondary side of the NGT to the primary, and then it will go into the winding. But since it is a very low frequency AC voltage, so it will not create any problem. Why? We will discuss. Because huge capacitance is present between the stator winding and the earth due to the insulation of the winding, and also the signal which is injected by the voltage injector are of very low frequency. So capacitive reaction will be very high. Xc, because Xc is equal to 1 by 2 pi Fc. But what will happen when there will be a fault? When there will be a fault means the insulation will break. So the capacitive tense between the stator winding and the earth will be weaker, and a, a resistive current will flow through the NGT. The same current will also flow through the secondary winding and the NGR. So, as there is voltage is present, current is coming through the resistive winding, so the resistance VYR resistance will be sensed by the relay. Now try to understand one thing, that when a voltage is injected and a fault occurred, then the resistive current will also flow through the NGT, and that current will be sensed all in the secondary of the NGT. So voltage is there, current is there, so V by I is equal to R. That resistance will be sensed by the protection relay to protect the 5% of the winding. In general, I is always 0. So V by I will be infinity. But when there will be some current, V by I will be some resistance. Calculated resistance will always be lesser than the setting resistance. As soon as it will sense the resistance, it will trip the breaker. So, finally, coming to the conclusion that 95% of the stator winding is protected by a relay which works on the principle of voltage drop, and the remaining 5% to complete the 100% of the winding protection is by measuring the resistance. So 100% will be protected by using the voltage drop plus the resistance. Thank you. If you have liked the video, please press the like button. Please like, share, and subscribe. Thank you. Good, take good care.